Hi everyone, just me again. I'm now watching two additional systems for next week, middle of next week. They're not anything big, but I do think they deserve paying attention to because they can still cause some hazardous weather conditions based on the types of systems that they are. Um, so right now we're looking at the European models since the GFS kind of fucked me over last week. I'm gonna going forward. I'm going to look at the Euro model first before I look at the GFS and the NAM, because the Euro had the right idea with the last storm, and it might be good for me to look at the ensembles too. If I have time, I'll do that as well. But typically, when you're far out and you're trying to forecast storms, you want to look at the ensemble models as well. And what that is the ensemble models um, are basically one model member just with different initial conditions. So basically, it's like the GFS, but with um, 30 different model members with different initial conditions. So you get 30 different model solutions from 30 different initial conditions, but from the same model. And that really helps to narrow down some of the variability. So before I look into doing that, let's just go ahead and look at the Euro, which I actually do think has a pretty good handle on next week. Um, and we're gonna see a type of system that I don't believe we've seen this year yet, or maybe once we did. God, all these trains and sirens. Oh my God, I'm sorry, guys. Um, okay, so we're looking at the 500 millibar vorticity map from the Euro on Sunday this weekend, Sunday morning. We're gonna go forward. The first thing I want you to pay attention to is this feature. This is a shortwave trough coming down because the northern jet stream is dipping down now. It's coming down, or starting to. It's going to come further down than this, but it's starting to come down. So you have an upper level low over, I don't know what part of Canada that is. Just know that it's part of Canada. That this upper level low is up there towards the Maritimes up there, and there's a cold front draping from that low. And this is Tuesday evening, and with this upward motion out ahead of it, there's not a lot of moisture associated with this system, but what I think may happen, and this is Tuesday evening again across the Northeast, and probably earlier in the day going further back towards the Great Lakes, I think we can see some snow squalls. And again, um, a snow squall is basically like a mini blizzard. That's the best way I can describe it. It lowers visibility to less than a quarter of a mile. It produces quick, heavy snow, usually lasting 30 minutes to an hour or less. And it can produce quick accumulations of like 1 to 2 inches per hour. So you could end up getting a few inches from a snow squall in a very short period of time with whiteout blizzard conditions. So um, they can be very dangerous. Now, typically you want some instability, even if it's weak, to get snow squalls. I'm not seeing any instability present with this front, which is kind of disappointing because I like snow squalls. But I am seeing a lot of wind shear, which might overcome that idea of not having any instability. So I'm not throwing in the towel yet that we see snow squalls on Tuesday, but right now I would still say the probability is probably low. But we do have this cold front coming through, and that's going to set up for the next system, which is this stretched out piece of vorticity behind it, and which brings in another shot of Arctic air. And when I say Arctic air, I mean Arctic air. It's going to be cold. It's going to be ass cold after this comes through. So, and you see it becomes tilted, and this color is very deep and very dark. So it's actually a pretty decent system. Okay, so what is it? It's called an Alberta Clipper. And I'm going to actually post a video from AccuWeather in the description for this video, where they go over what an Alberta Clipper is. But if you go back here, you see it goes back. It's forming near the province of Alberta in Canada. Now, personally, I don't know which provinces are which, but I'm just assuming that that's where this is kind of forming from, because that's what it looks like. It looks like an Alberta Clipper. It's named that because that's where it forms. And what an Alberta Clipper is, it's a quick moving system. It's usually progressive, meaning that it usually does just go out to sea. It's quick moving, but it can produce a moderate snowfall in the areas that it impacts. It tends to strengthen as it gets closer to the coast. So usually it'll produce a light to moderate snowfall, not a it will not usually produce a heavy snowfall. And there's one exception to that rule. And that exception is if it dives deep down towards the Delmarva, comes off the coast, and then re-strengthens off the coast and comes up the coast and becomes a nor'easter. And that can happen sometimes. However, with this particular Alberta Clipper that I'm watching for the middle of next week, the tilt of the jet stream is just not ideal for that. It's going to be progressive. So it's going to be a light to moderate snowfall for everybody. So I think before it strengthens, it's like a 1 to 3 across the Great Lakes. And then when it gets towards the coast, like Pennsylvania, the southern Adirondacks, and the Delmarva and the I-95 is more like a 2 to 4, maybe a 3 to 6, depending on how much it strengthens. The European has more like a 2 to 4. I think that's more realistic. And I think the track kind of makes sense based on how far south the jet stream is going to be moving. So, we'll see. Now remember, the storm always forms on the southeastern edge. So to the north is where you're going to get the heaviest snow. So that would point towards southern New England, Long Island, New York City, and going back Pennsylvania, southern Adirondacks, Catskills, and then I think Boston would be on the northern end of this. And then after southern New England, you'd probably be too far to the north. Now, if you go to the GFS, see, this is where you run into problems. I'm just going to do this really quick. Okay. Okay. Sorry. My computer has a virus. Okay. The GFS has it weaker and to the north, so it doesn't dig far enough south. But it's also very robust with the snowfall amounts, and that to me doesn't make sense. So I'm leaning more towards a further south solution as proposed by the European model, and a more moderate snowfall solution, because the GFS has 6 to 12 on the northern end of this Alberta Clipper trough here. I just don't believe that. I did want to show the jet stream, so let's just do that for the Euro, and then I'm going to cut this video short because I rambled on way too long. Okay, so here we go. So here's the jet stream for the Euro, and look at how far south it's penetrating. So that's why that Clipper, they're going to talk about that in the AccuWeather video. The Alberta Clippers ride the jet stream. They ride the northern jet stream wherever it is, and they follow it and they come down. But notice how the jet stream is not tilted so that it comes back up the coast. At least not that much. But we are on the northern end of the jet stream, so we will be seeing upper level divergence, rising motion at the surface, which is why it strengthens as it rides the jet stream down into the Atlantic Ocean. And then, just to show, I still have a couple minutes to show the GFS. Look at this. It's the northern jet stream is not dipping down. In fact, the dip is further to the west. So, I mean, it's difficult to judge which solution actually is correct. I mean, it's winter right now, and I believe we're in a La Nina, so I believe that the southern jet stream, which is a lot stronger in this run, typically is not that strong this time of year. Usually the northern jet stream is stronger, and we're going to be having a front coming through the day before. So it would make more sense for me that the Euro is correct over the GFS. Let me see if I can get the ensembles. Let's do the GEFS. This is the one I normally do. Let's do the yeah, so the it's going to be a close call. So what I'm seeing here is that with the ensemble solution is that there are some members of the GFS that do dip it further south, because the ensemble, this is the ensemble mean, so this is the average of all the members of the GFS that have those different initial conditions. And what I'm seeing here is that compared to the regular GFS, which is a deterministic model, the ensemble mean is further south. So that does mean that some of the members of the ensemble family in the GFS are further south. Okay, so that does support my theory that the European model is potentially correct. I do not think that the deterministic GFS is correct, to be honest with you. But I could be wrong. I was wrong last time, so we'll see what happens. But I think looking at the ensembles here from the GEFS gives my theory credence that the jet stream and the Alberta Clipper will likely be further south and stronger. All right, that's going to do it for me. Again, every 2 days unless something severe develops. All right, take care.